Hello everybody, welcome to our Math 20-2 series on our unit on quadratics. For many people, it's a lot of information in this unit, and it's hard to remember to put everything together. The one challenge with this is everything seems to be related. Once we do one thing, we can then do something else, and so on and so on. So this is one of those units that really spirals on itself. It is a very interesting one. It is one of the more involved algebraically in this course. So I hope this this video series, this playlist here, will help some people. And again, in the description boxes, you'll find all the links to resources that you need, namely a blank copy of this if you wish to print it out and follow along with me. Or the solutions if you happen to just look at this and try some out on a blank sheet of paper. You can see the answers as you go. So let's take a look at, this is lesson 1, some of the characteristics of a quadratic function. And the quadratic name is given to things that have a degree of 2. So I'm just opening my calculator here. So anything that's got a degree of 2, we're going to call a quadratic equation or a quadratic function. Now the degree is basically your exponent, right? So the highest exponent that we can see on a variable here, well, is a 2. So it's always going to have an x squared inside, okay? It's going to have a squared term. And it does say specifically here that a is not equal to 0. Because if a was 0, so a is just a coefficient in front of it, it's just a number. So if a was 0, well, anything times 0 would make the resulting product 0 as well. So really, if a was 0, this would just be something that represents a linear function, something that just graphs a straight line. And what we're going to see here in terms of something that's quadratic, the shape is a little bit different than what we're used to. So I'm going to graph this first one here. If I press my y equals button in the top corner, well, I can put it in, and it says x squared plus 3x plus 2. And then if I hit the graph button, which is top right, we'll see that shape being drawn. So all we're going to do is just draw out, the little picture here, just so we have a reference to look at. So it looks something like this. And there's going to be arrows on the top because it could really just go forever. So I'll move this cursor up a bit, and I don't know, it doesn't make my screen move actually, but if I zoom out by increasing the maximum value for y to maybe, let's say 50, you'll see that it just keeps on going. So I'm going to put arrows on the ends to tell me it goes forever. But now I'm going to graph b. And b is almost the same equation. The only thing that's different is that squared term has a negative sign in front of it. So I'm just going to put a negative sign into this and graph it. And what you'll notice is now it looks very, very different than how it did before. Okay, my graph looks something like this now. Well, now it's opening completely the other way, and now my arrows are pointing downwards. So that negative sign really affects a whole lot here. But you can see the same general shape. It kind of looks like a U. The blue one kind of looks like a happy face. The red one, a little sad face, if you were to think about including the eyes for a face there. So the direction that it opens is pretty important. And we can try out 2a and 2b as well. So I could even do 2x squared plus 5x plus 1. Graph that one. We'll see what happens. Okay, now it looks a little bit more narrow than the original one did. And now, I also have a part that's underneath my x-axis. And again, b is very similar. In the only thing that's different is now there's a negative sign in the front of it. So we'll graph that one as well. And you'll see it almost looks the same as that red one we had before, but a little skinnier, right? It's a little skinnier than the original one. So really, these pictures just give us an idea of what these types of graphs are going to look like. And the one thing that's super important here, we changed that coefficient, the number in front, from positive to a negative. And when we changed it, the graph of the function opens the other way. oops, the other way. In this case, downwards. Okay, so that negative sign is a big deal, and it basically is going to tell us if my graph will open upwards or downwards. Okay, the direction's important, it has a meaning. Okay, well again, I could graph these as well, and now what you'll notice is the only thing that we're going to change is really the number on the end. And if you remember the word for that, really that number with no variables was a constant number. Okay, so we called that a constant. So we'll graph the original one here, x squared plus 3x plus 2 graph. Okay, and it's really on the left side of that y-axis line. So there's like my point, and my graph looks something like this. Like, it's not perfect, but really it gets us a general idea. And we'll graph number 2 here, and what we'll change is that number on the end. And we'll see what happens to this. I'll change it from a 2 to a 5, and then hit graph. And what you'll notice is now my graph looks like it's gone upwards a little bit. Okay, so we'll graph this one as well. It looks like it went up a bit. Now originally it was at 2, now it seems to be at 5. Okay, so that moves my graph upwards. Well, what happens if I graph number 3 here and change that number not from -5 to -2? And think about it in relation to that first one, what we did. Let's see, plus 3, minus 2. Okay, I graphed the same thing. And really what you're going to see is now the whole graph is moved in a completely different direction. Now it's somewhere over here. And now it's somewhere over here. And you can see like there's a point on the bottom here that keeps moving around. Originally it was on the x-axis. In green it was a little above it. In the purple one it's, you know, to the right side and a little bit down. So there is something happening here when I change this constant number, and maybe let's see what happens if I change it to 5, but -5. And we can see, well again, like it really just shot my graph downwards quite a bit. So I'm going to zoom out here. So I just press my zoom button. Option 3 is zoom out, and hit enter, and you'll zoom your graph out a little bit. And I can see that it really, I have to zoom out again to even see that bottom part of the graph. So it really, that number moves it quite a bit, and it made it very, very narrow. It made it very difficult to see. So it really controls a lot about this, that constant number. Okay, and what we can say is when the value of a is changed, well, it's not a this time that we're talking about. We're talking about our constant number, so really it should be c. That was a little bit of a typo there. So we'll say when the value of c is changed, the graph can move left, right, up, or down, right? We really don't have a set way to know which way we're going, right? Originally I had the black one, and then, you know, the green one I moved up, the purple one I moved right, the red one I moved down quite a bit. So there's really not a set way right now which we're going to be able to tell which way it is we're going. Okay, there is a way, but with the information as we're just starting out, really we're just looking at the graphs and the equations and seeing what happens. So I don't really know right now what it really controls, but it does move it around quite a bit. Okay, now this page will give us a lot of information about these types of graphs and equations and what variable controls what. So a quadratic function, which again is of the form y is equal to ax squared plus bx plus c, again a can't be 0 or else it's linear now, is a function with a degree of 2. Okay, which is basically exactly what we said before, and that degree of 2 means you've got one of your exponents as a 2. Okay, the graph of a quadratic function has a name, and it's called a parabola. Okay, a parabola. So if you ever hear something about a parabolic trajectory, you hear it all the time in stocks as well, if something's going parabolic. So usually you want it to be the first case where the stock keeps going up and up and up, because that's generally where people make money. And then it all comes to a crashing halt if it's parabolic in the other direction and just drops and loses all of the value. So there are two cases. But here's some examples, right? It could be any of the four is really what they look like. Now, if a is positive, that number in front of x squared, the graph is going to open up. Okay, it looks like the smiley face cases. So the first two here are where a is positive. Now, if a is negative, it's not necessarily a bad thing. It just means that the graph opens in a downward direction. Now, the constant term of c, that is the value of the parabola's y-intercept. Essentially, that is where our graph will cross the y-axis. So we graphed a few of them before, and we can take a look at those constants now. Well, the first one crossed at 2, the green one crossed at 5, the purple one I didn't draw correctly, obviously, because it should cross at -2. So I should be down there a little bit. So there it should cross at -2. And the red one at -5. Okay, that is really what that variable tells us on the bottom, or in the bottom, on the end of that equation, right? It's going to tell us where we cross the y-axis. And again, the reason I know that is because any equation, if you let the x value equal to 0, every y-intercept is on that y-axis. Every single point on there has an x value equal to 0. So if you plug 0 into this equation, you get 0 squared plus 3 multiplied by 0 plus 2. Well, 0 squared becomes 0. That's what it simplifies to. 3 multiplies with 0, again to simplify to 0. So the only thing I'm left with is 2. So it will tell me where I cross that y-axis. So if x is 0, y is 2. And that's the same thing for all of them. The same thing is true for all of them. Now, each of these is symmetrical. It's one of the properties about it. There is a line that you can use to cut it in half, where the left side and the right side are the same. And it will always be a vertical line through what we call the vertex. Okay, the vertex is the point that's either the biggest or the smallest point on this graph. In other words, the value of it could either be a minimum, okay, the lowest point on this curve, or the biggest, right? It could be a maximum, the largest point on that curve. And if I know what the vertex happens to be as a point, as the coordinates, I'm able to find that symmetry line. Okay, so there's a lot of definitions here, which we'll talk about throughout, this video series. And again, the vertex is where it reaches our maximum or minimum value. Either it's at the top or it's at the bottom. Okay, and that depends on which way this opens up. And we've got two things, a maximum or a minimum value. It's just basically the y value of the vertex. So either the one at the top or the bottom. Okay, it's only going to have one of them. Now your axis of symmetry is the line that goes through the vertex that cuts it in half. Okay, the line of symmetry, in other words. Now, if you know what the vertex is, it's always going to be the x coordinate of it. Okay, vertical lines always have the same equation, and they are always x equals lines. Okay, your x and y-intercept are the same as you've learned them in the past. X-intercept where you cross the x-axis, y-intercept where you cross the y-axis. Okay, the other two things on the bottom here are domain and range. Again, something that's not new, but domain describes all of the possible x values that we could have. Now, for any parabola, it's going to be any real number. It won't matter what value of x I pick. As long as I can put it into my equation, I will get a y value. So there's no restriction on what x can be, but there is a restriction on y. Because for some of these, there is a point where you can't go any lower. Right? There's nothing underneath this graph, so I can't have a y value smaller than my minimum, which logically makes sense. On the other side of things, I can't have a y value bigger than the maximum because, well, it's the biggest one I could have. Okay, so our range is going to depend on where our vertex is. So let's look at a couple of examples that talk about all these things, and we'll try to start piecing things together here. So we're going to find all these things based on, the graph that you're looking at. So if you think about the direction it opens, you can follow it around with your mouse, pencil, whatever, but the two endpoints at the top, they continue to point upwards forever. I just can't see the whole graph because, well, I can't draw a graph that's infinitely large, but it does open in an upwards direction. Okay, and another reason I know that, if my equation is x squared, well, the x squared term is positive, right? So I know it opens upwards. Coordinates of my vertex. Well, if I look for it on the graph, there's the point of it, right? And it's right on the origin. So this is really 0, 0. Those are my vertex coordinates. Okay, when x is 0, y is 0. The minimum or maximum value. Well, if I look at this graph and I think about this, if it opens upwards, well, that vertex is the lowest I could go, or there's nothing underneath of there. So I know that my minimum value, the minimum, is at a value of 0. Okay, the y coordinate is 0. Maybe I'll write it as minimum at y equals to 0. Now the equation of the axis of symmetry, well, that's going to come from the x coordinate of our vertex. Since x is 0 on our vertex point, the line that cuts it in half is when x is 0. So along this green dotted line that I'm drawing in, every x value is 0. Okay, that's the line that cuts this in half. Now you can think about your x and y intercepts, but they both happen to be the same thing. They happen right at the origin. So I know that for my x-intercept, x is going to be 0. For the y-intercept, y will also be 0. Okay, that's where they cross both of them. Now the domain happens when x is really any real number. So the only thing that x can be, well, is anything. So the set of x values given the restriction that x is any real number. It doesn't really matter what x is. If you pick something, you can put it into your equation, square it, and you'll get a y value to go with it. The range, however, is different because there is a point at which I can't get any lower. Right? There's a y value here that's the lowest. So when you think about range, you should be thinking about horizontal lines. Okay, and that horizontal line I've drawn in red basically controls where y values exist. So if I left the red line right here, there would be y values of 3 in two places, right? A y value of 3 happens when x is like negative 1.5 or positive 1.5. There's two places where it happens. If, for example, I had that red line right here when y is equal to 1, well, if x was negative 1, y would be 1. There's 1 point. If x was positive 1, it would also be positive 1 for y. There's my other point. But now there's a place where I can't go any lower than it. Right on that x-axis line is the lowest place I can put it. None of the graph exists underneath. So for your range, it's going to be the set of y values given that y has to be greater than or equal to 0. Okay, that is the smallest y value that can exist. There's no y values here of negative 1 or negative 2 or anything else. Okay, so I've got all the pieces. We've talked about all of them. We can try it again with a different graph. And it's moved slightly, so think about the same questions. Direction of opening, this time it's down. Coordinates of the vertex. Well, there's my vertex right at the top this time. This is the highest value it can be. Your coordinates of it, x is 1, y is 4. Okay, and from that, I know the maximum or minimum value. Well, I know this is a maximum because that vertex point is the highest point on here. So the value of it is 4 as a maximum. So the maximum at y is equal to 4. The axis of symmetry comes from the x value of that point. So x is equal to 1. And here's the symmetry line to cut it, right? Vertical line through x is equal to 1. Okay, so there's my line. The x-intercepts this time. Well, now I've got two x-intercepts. Right, remember, that's where we cross the x-axis. Add that in there for us. That's where we cross the axis. So here's one of them, and here's the other one in purple. So those 2 points are negative 1, 0, and 3, 0. Right? This happens, there's 2 places where it crosses. There is, however, only one y-intercept. So look for where you cross the y-axis, and this one happens at 0, 3. And again, that's the constant in your equation. Everything kind of goes together. Domain, again, you can think about x is going to be anything, and that will always be the domain. unless it's a word problem. For range, we can use our vertex to help. So I know the biggest number I could have for y is 4, so everything else has to be less than 4. Or it could be equal to it. But other than that, it could be anything else. So that y-er and x-er that you see there, it just says that y could be any real number, x could be any real number. Okay, as long as it's less than 4, I've got every y value accounted for. Okay, there are a couple others as well, which you know we'll talk about, because then we get into like some of the other word problem sorts of things. And maybe I'll cut this video, we'll break it up into 2 parts. So we'll do characteristics 1 and 2. We'll do 2 pieces. So again, direction of opening here you can think about as being, well, up. Because you can see it looks like a happy smiley face. The x squared term is positive. Find your vertex, right, your coordinates of it. There it is. That's the lowest point. So if it opens upwards, you're going to have a minimum at, this one is 1, minus 1. So there's my vertex at 1, negative 1. My minimum value, the lowest y value that you can see on here, is when the graph is equal to negative 1. That's the y coordinate of your vertex. So the minimum is at y equals minus 1. The equation of the axis of symmetry is the x value of that vertex. So x equals positive 1. Because there is the red dotted line that cuts it in half. Okay, straight down the middle. X-intercepts, again, there are 2. One of which is at the origin, 0, 0. The other one is at 2, 0. Okay, 2 separate places where it happens. The Y-intercept again happens right on the origin. Okay, so 0, 0. Sometimes that point might be the same, and that's okay. It could totally happen. And you can see it here in the picture. Domain. Again, x can be anything. It doesn't matter. Okay, as long as this is not a word problem, x can really be anything. The range, again, comes from the vertex. So find that lowest point. We know it's a minimum. Everything else should be bigger than that point. Specifically, the y value of that point. So our vertex has a y coordinate of negative 1. Y has to be bigger than or equal to negative 1. Okay, so there it is. They all work very much so the same. So if you've seen a couple of them, they are all identical. Okay, last one we'll do here before, actually, we'll do that part as well, and then we'll talk, okay, this will work out good. So we'll do D here as well. Direction of opening, again, it opens upwards. Coordinates of the vertex. Well, find out where it is. This time again, if I open upwards, I have a minimum. And it happens, and I have to take an estimate here. And it looks like I'm about halfway. So halfway between 5 and 10, 7.5. So this will be, let's say 3. This is 7.5 just as an estimate. And I know halfway between 5 and 10 really is that I'm counting by 5s. So I know half of 5 is 2.5. So 5 plus 2.5 is where I got that 7.5 number. Okay. Coordinates of my vertex then, let's use those. So 3 and 7.5. Minimum or maximum value. Again, it opens up. So again, I know it's a minimum. So the minimum is at y equals 7.5. That is the smallest y value that I can have here. Everything else is bigger. Axis of symmetry line, again straight through the center, through that vertex, which will always be your x coordinate. So x equals 3 is our line of symmetry. X-intercepts. This time, it doesn't cross the x-axis. There are none. And sometimes that's possible. Right? There are no x-intercepts here. There is, however, still a y-intercept, and you can see it either from the graph at 25 or in your equation at 25 as well. So my x-intercept is going to be when x is 0, y is 25. There's my point. Domain, always the same. X is any real number. Range, again, comes from that vertex. 7.5 is the minimum value, so that y has to be greater than or equal 27.5. Okay, so always from the vertex. So if you have a graph, it will tell you a lot of information, and all of that is what we're going to use to, in future lessons, start to solve some problems and interpret all of these algebraically. Okay, that's where we're going to go with this. You could also draw this out by hand as well to see, you know, what it's going to look like. So we can be a little bit smart about this. And if I know my calculator and how it works, it will give us a table of values here too. So I'll show you how to do that. We'll put in our equation. So in y equals, we'll do x squared plus 4x plus 3. And then we're going to press the second key and graph. And what it will do is literally give us a table of values that relates to the graph we've chosen. So we're just going to scroll up until I get -3 at the top, just like I have. And we're just going to fill in the y's. So I've got a 0, then -1, 0 again, 3, 8, 15, and 24. So I've got my table of values filled in. That was pretty simple. And the other way that you could do this by hand, take an x value, put it into the equation, and what you'll get out of it is a y value that you could fill in the table with. So you could do that as well, but really no need. The calculator did it for us. But now I'm just going to graph these points. And we always graph the x coordinate first, then the y. So when x is -3, y is 0. So I've got one of the points right on my x-axis. So I know this point is an x-intercept. One of the other points is when x is -2, y is, well, 1, -1, sorry. So down here, -1 and 0 again. Okay, so there, right there, I've got another x-intercept. And 0, 3. So 0, 3 somewhere here. But I know that point is going to be a y-intercept. Because again, I can see that in my equation. There's my constant of +3. And I know if I'm on the y-axis, well, that's my y-intercept. Right? I know that by definition. What we can do is throw the other points on there as well. So we can do 1, 8, somewhere here, 2, 15, so somewhere like this, and the last one is 3, 24, somewhere over here. So I've got, you know, a good, you know, starting point for my graphs. Let's see if I can, you know, connect these here. And, you know, iPad's pretty smart. So there we go. It gives me a nice curve. It's not perfect, but, you know, it gets the point across. So my arrows are going to really tell me it continues on. But there's what it will look like. You know, I've got a portion of this. I really have the right side here. I kind of know this is the vertex already because I've got my two intercepts on either side of it. So I know that the point in the middle of those intercepts is actually the lowest I'm going to go. And there's my symmetry line. So I know that already. The value in between my x-intercepts is also my vertex. It happens to be a minimum because this opens upwards. If it were a maximum, it'd be like the highest point it could go. So I know that just from looking at this table as well. This is super helpful. It was pretty quick to get using my calculator. The last couple things we'll talk about before we wrap this one up as our part 1 here. Is, you know, we can determine the x-intercept, the equation of the axis symmetry, coordinates of the vertex, domain and range. Really, we talked about all those things. So I found the two x-intercepts already. So we'll just fill them in here. So as coordinates, I've got -3, 0 and -1, 0. Okay, those are my x-intercepts. Y-intercept we said was 0, 3. Axis of symmetry. Well, we know it's the line that goes through them, so if I know the vertex, it's the x-coordinate of it. So x is equal to -2. So all the same pieces are here as well. Coordinates of the vertex, -2, -1, straight from our table and picture. Domain again, x could be anything. And range comes from the y value, right? The y value of our vertex. So -1 is the lowest y value. Everything else has to be bigger than it or equal to it. So exact same information found using a table and also a graph. Okay, determining characteristics given the x-intercept. So now we're just going to give some different information to do really the same thing. So I know that the equation I'm given, x squared minus 2x minus 8, has x-intercepts at -2 and +4. So I'm going to graph them. One of them at -2, the other at +4. Okay, there's the two x-intercepts. Now, is it opening up or down, and therefore will it have a minimum or maximum? So if you think about the first term there, it's x squared, but it's positive x squared, so I know this is going to open up, and if it opens upwards, it will have a minimum. Okay, so that's important. So now I'm going to really know where my vertex is going to be. It's going to be somewhere below my x-axis, given where my x-intercepts happen to be, and that line is exactly halfway between the x-intercepts. So if I know what the values of them happen to be, we can essentially take the average of them, so add them together, and then cut them in half to see where they're going to be. Or you can think about just counting this out. Right? If one's at -2, one's at 4, well, 1, 2, 3, 4, 5, 6. Those numbers are 6 units away from each other, so the halfway mark should be really 3 units away. So 2, 3, right around x is equal to 1 will be your halfway mark, because from that line I can go 1, 2, 3 units to the right to get to one intercept, and 1, 2, 3 units left to get to the other one. So I know that my symmetry line is the line halfway in between. If you want to show that algebraically, your axis of symmetry you could do as -2 plus, minus 4. Nope, sorry, I want to add. And then cut it in half. So if I add them together, 4 plus -2 is 2. Divide that by 2, and that's where you get the 1 from. And that 1 is actually my x value. So therefore my line is x is equal to 1. Okay, so you can add them up, divide by 2, so just take the average of them. Okay, add your intercepts, cut them in half. Now if I know what the x-coordinate of my vertex is, I can find the y-coordinate by plugging that x into our equation. So if I know that my equation is y equals x squared minus 2x minus 8, we're going to put in x as 1. So make a substitution, and what you'll figure out is that y should be equal to 1 minus 2 minus 8. And when you simplify all of that, you end up with, well, let's plug this in. You know, negatives are not my strong suit. So 1 minus 2 minus 8, -9 as a y value. Okay, so there's the y-coordinate of my vertex. Okay, so now I know along that line, that's my symmetry line, I know that my vertex is going to be somewhere about there, right, at 1, -9. And I can extend that symmetry line all I want, and what you'll notice is it has to go through that vertex, which it does, so that's excellent. The other thing that would be very helpful to know is the y-intercept. And again, I could graph that by looking at that constant in the equation, right? That's going to be my y-intercept. So if I throw that on the graph as well, at -8, well, now I have 4 critical points. Okay, and I see that they're critical because they're super important. I've got my x-intercepts in pink, I have my vertex in blue, my y-intercept in red, so I have enough information now to draw a very, very rough sketch of what this is going to look like, right? There's basically the shape that this will follow. And if you put your domain and range on here as well, the set of x values given, there's no restriction on them. It could be anything left or right. The y values come from that vertex again. So if -9 is the lowest it could be, the graph says it has to be everything above it. So greater than or equal to -9. And you can double check this, just graph it, right? Put it in your calculator. X squared minus 2x minus 8, and then press graph, and you should see it somewhere down here. Wait a second. Oh, I'm just so zoomed in. There we go. Let's fix that up. There we go. So now my graph goes right down to 8 through the -8 through the Y-intercept. There's my vertex a little bit over, and there are my two x-intercepts of -2 and 4. So all of those points are on there as well, which is exactly what we've talked about in this 35-minute video. So I'm going to cut this one off here. We'll break this lesson up into 2 parts. So this will be part 1. Part 2, you'll see, linked up in the top right corner. So I hope that was a nice introduction to you for quadratic equations and functions and all of the things we can read from a graph and their equations as well. So we'll start to do a lot more with this in the next few videos. So again, take a click on that link just up above to see part 2. And until we see you in the next one, take care of yourselves. Have a great rest of your day.